In this presentation, we're going to look at the basic features and functionality of S3 or Simple Storage Service. It's essentially durable, cost-effective object storage, which begs the question, what is an object? An object can really be anything, any sort of digital file, such as binary data, images, zip files, or raw data, such as video. It can also be text data, like CSS, JavaScript, SQL dumps, or code, or any combination of the above. Objects are placed into buckets. A user has to provision a bucket before they can put objects into it. Buckets are globally unique namespaces. Think like domain names. They're unique across regions. A user has to first provision a bucket in a specific region, and then they can add objects into the bucket. Every object inside of S3 is web accessible, to the owner only by default. Of course, the owner can open up permissions so that the entire web can see it as well. Objects consist of a key and a value. The key is the name of the object, which includes the bucket name. Here we see that I've created a bucket called Infinite Skills and uploaded a graphic called aws-logo.ping. The values contain the bytes of the object, how to actually re-represent the object when it comes back out. One important thing to note here is that although this looks like a folder, it's actually a key into the file. The implication of this is that those slashes in between, although they look like file paths, they're actually just part of the key itself. There's also legacy URLs and a more compact and possibly preferred URL. You can see the one on the top has the bucket name after S3 Amazon AWS, whereas the one on the bottom has the bucket name as part of the domain. Either can be HTTP or HTTPS. Many clients, including the AWS console, expose the keys as folders. A popular solution named Cloudberry actually does this as well, so that I can browse through anything that has Infinite Skills / and it looks like those are actually contained inside of the folder. Again, this is just a key. It's very easy to CNAME a vanity URL to your bucket. For example, if I created the bucket name of Infinite Skills-images, but I had a desired domain name of images.infiniteskills, I can easily CNAME the Infinite Skills S3 domain as images.infiniteskills.com and then include images.infiniteskills.com in my references to it. Objects also have 4 types of access control. They're IAM policies, bucket policies, ACLs, and query string authentication. IAM policies provide the finest grain of control possible. They can limit to user, group, by IP, by date, and so on. But they're arguably a little bit tougher to use inside of S3. You first have to create an IAM policy, which is a JSON document, and then attach it to a specific bucket or resource. Bucket policies are a legacy solution, but they still work very well. They restrict read and write permission of the bucket only to specific or all users. Bucket policies do not cascade to the objects below. If you put a read on a bucket policy, it means you can see the files inside of that bucket. It's not read all objects inside. You can filter also by IP for VPN solutions. More information on bucket policies can be found at this URL. ACLs, or access control lists, are probably the #1 way that users control permissions through the web GUI. They're a legacy solution, but they still work well. This restricts read and write permission of a bucket or object to specific or all users. Again, ACLs do not cascade to objects below. If I put read bucket, that means I can see the directory list, not read the contents of all the objects inside. Again, this is what we see when we access the AWS console, and we grant permission so that everyone perhaps can see a CSS file. More information on ACLs can be had at this URL. The final form of authentication is query string authentication. This gives users expiring access to read or write to a specific object. The grantor, whether that be you or an application, assigns permissions such as read and write and assigns an expiry in seconds. It finally signs the request with access and secret keys. Any user with that URL can then access the signed object with the given permission inside the given expiry time. This is essentially what a signed request looks like. You can see here that we have a signature at the end. Each object also has metadata associated with it. This data can be things like headers, such as the content type, the date of creation, and x-amazon-something metadata. The x-amazon parameters control AWS side configuration. The user modifies these indirectly by changing storage class, version, so on and so forth. More information on metadata can be had at this URL. S3 has 3 different storage classes for objects. The first, or standard, is called 11.9's durability. That 11.9's essentially means that if you have 1 million files stored in S3, you're going to lose one of them every 10,000 years. It's hard to get more durable than this. It does come at a higher cost, but it's the default. Next up is reduced redundancy storage, which is 4.9's durability, at about a 20% discount. This means that if you have 10,000 objects stored in S3, you're going to lose one of them probably about every year. It's great, especially for reproducible assets. The final storage class is Glacier. It has standard 11.9's durability, but its big drawback is that it has a queued retrieval time. When you go to retrieve your data out of Glacier, your request gets queued with many others, and it gets delivered perhaps hours later. The big sell of Glacier is that it's roughly about 1/10 the cost of standard, which makes it a great solution for backups and archival. Some notes on RRS. RRS can fire SNS notifications when an object does go missing. You can subscribe an HTTP endpoint to automatically recreate the missing object. For example, you could store an original image in S3 standard with 11.9's durability, and then a watermarked thumbnail in S3 RRS. If the watermarked thumbnail ever goes missing, SNS can notify an HTTP service, which can go back and recreate the watermarked thumbnail from the original. S3 has 3 facets to its pricing. The first is storage. S3 storage costs start at around 10 cents per gigabyte per month for standard S3, with the monthly gigabyte charge getting cheaper as you use more. It's also stored per bandwidth. Bandwidth in is free, and bandwidth out to the same region is free as well. Bandwidth out to out of region starts at about 12 cents per gigabyte per month, again with cost growing cheaper the more bandwidth you use. Requests are also a charging facet of S3 pricing. They start at about a half a nickel per 1,000 requests. In summary, S3 is object storage, native online, contains key value and metadata, and it's the preferred choice for serving static files, has a lower cost, is extremely durable, and very, very scalable.